In this video we are going to talk about changing recurring decimals to fractions. When we divide, let's say, 7 by 10, we get 0.7, so this is called as terminating decimal because it just stops here. It is 0.7. That's it, it doesn't go on. Whereas if you divide 7 by 9, you're going to get 0.7777, and this bit goes up to infinity, and we call this as a recurring decimal. Now, in primary, we were to write that recurring decimal like this, but now we use this notation, 0.7 and a point on top of 7. Or you may sometimes see that they will be writing 0.7 with this short line on top of it, expressing that 7 recurs. Now for this example, we know that we divide 7 by 9 to get this recurring decimal. So as a fraction, I can write this as 7 over 9. But I started with the division, so I know. The other way around, if I am given the recurring decimal and I'm going to ask to find the fraction, then I have to do the following. Let's look at this example. It says change 0.26 recurring into a fraction. Now, assuming that it's going to be a fraction, we can write a fraction for this number. We can say let that fraction be x. So it's going to be x equals 0.26 recurring. Now what I can do is I can multiply both sides by 10. If I do that, I'm going to have 10x equals, now just because when I multiply by 10 the decimal point will go this way, one digit, it's going to be 2.62 and so on. Or I can just show it like with the dots, so it's 6262 and so on. Right? Now, if I multiply this by 100, then I get 100x equals 26.2626. Now, the idea is as follows. I want to get rid of this recurring decimal part. Okay? So if I consider x equals 0.26 recurring and 100x, which is 26.2626, so it goes like that, it's recurring, you can see the decimal part is the same. It starts with 26, here it starts with 26 and go on. Whereas for 10x, it starts with 6. It doesn't start with 2. So it is in a position that is 6262, not 2626. So I can ignore this, right? And I can go with these two. If I do a subtraction, right, if I take away, then 100x minus x will be 99x, whereas 26.2626 recurring minus 0.26 recurring. So although there are infinitely many digits, I can take this number away from this, cancelling out the decimal part. So it's going 26 minus 0, which will be 26. After that is easy, it's just solving a basic linear equation. I divide both sides by 99 to leave x alone, so that I'll have x, the fraction I assume to exist, will be 26 over 99. So this is how I can convert a recurring decimal to a fraction. Now let's look at this example. It says change 1.58, 8 recurring into fraction. So I'll say my x fraction will be 1.58 on the 8 recurring. Now if I multiply by 10, right, 10x will be 1, 5, so it's going to be 15.888 like that, right? And if I multiply by 100, then it's going to be 100x equals, now this time it's going to go like 2 digits, right? So I will write 158.8, so this is recurring, of course, 8 recurring. Now obviously I can see that with 10x and 100x the decimal parts are the same, whereas in x it is not the same. It starts with a 5. So I can use 10x and 100x. I can use these two numbers to end up with my fraction. So what I'm going to do is I'm going to take away 10x and 15.8 recurring, this bit, from 100x equals. So I'm going to take away these two. So 100x minus 10x will be 90x, whereas when I take these away, I can see that just because the recurring part is the same, I'm going to take them away, they will cancel each other out. So basically it's going to turn up to say 158 minus 15, which will be 143. Now again, I'm going to leave x alone to find my fraction, which will be, if I cancel these out, x equals 143 over 90. So this is my fraction for this recurring decimal. Now it's always best to key this into a calculator and hit equal to find out whether you can simplify this fraction further, because you have to write down the simplest form. So write this fraction into your calculator, hit equal sign, and see whether you get something else as the simplest form. Maybe you're going to get this fraction itself, which will tell you that it is already the simplest form. But it's always best to check. Right. Now it's your turn. So you're going to convert these into fraction, and remember it is only this bit, 5 and 6 recurring here, 5 recurring here, 7 recurring here, and 2, 3, 4 altogether recurring in this decimal. Thank you.